NASA's TRACES mission, Unraveling the Mysteries of Solar Wind. Imagine a groundbreaking journey into the unknown, where we seek to unravel the secrets of solar wind and its impact on our planet. This month, a robotic space mission is set to launch, aiming to explore the fascinating realm of space weather. Leading this ambitious endeavor is the University of Iowa, spearheading a project valued at nearly $166 million, known as TRACES. At the helm of this mission is Professor David Miles from the Department of Physics and Astronomy at the University of Iowa, who serves as the principal investigator. TRACES stands for the Tandem Reconnect Ion and Cusp Electrodynamics Reconnaissance Satellites, Miles explains. However, the essence of TRACES lies in its goal to investigate how solar emissions interact with the space surrounding Earth. This mission will deploy 2 spacecraft, which will delve into the phenomena of space weather. While space weather can create stunning displays like the Northern Lights, it can also lead to significant disruptions in technology, such as satellite failures that can interrupt our phone calls, television broadcasts, and GPS navigation. Miles emphasizes the dynamic nature of space weather, expressing a desire to understand its complexities. The Sun is essentially a massive, fiery sphere of plasma, continuously emitting a stream of particles known as solar wind. This solar wind perpetually flows from the Sun towards Earth, he notes. At times, the Earth's magnetic field acts as a barrier, similar to how a rock diverts water in a stream. The 2 spacecraft will be positioned in orbit around Earth, venturing into the regions where the solar wind collides with the planet's magnetic field. We have designed the 2 spacecraft to closely follow one another, maintaining a tight formation. One spacecraft will pass through a specific area, and then, 10 to 120 seconds later, the second will follow suit, Miles elaborates. This arrangement allows us to gather closely spaced measurements, enabling us to analyze whether certain phenomena are accelerating or decelerating, shifting positions, or turning on and off. The key instruments aboard these spacecraft were meticulously designed and constructed at the University of Iowa, and they will be launched together on a single rocket from Vandenberg Space Force Base in California before the end of the month, although the exact launch date is still pending. With the University of Iowa leading this monumental $165.7 million mission, it marks a historic milestone as the largest external research grant in the university's history. But here's where it gets controversial. As we venture into this uncharted territory, what implications might our findings have on our understanding of space weather and its effects on modern technology? Are we prepared for the potential disruptions that could arise from solar activity? We invite you to share your thoughts and opinions in the comments below. Exploring NASA's TRACES mission, Understanding Solar Wind Interactions. NASA is set to embark on an exciting new journey with its Tandem Reconnect Ion and Cusp Electrodynamics Reconnaissance (TRACES) mission, aimed at exploring the intricate interactions between the solar wind and Earth's magnetic shield. This mission promises to deliver invaluable fly-through data that will enhance our understanding of space weather phenomena, ultimately leading to improved forecasting capabilities. The primary focus of this study is on the magnetic dynamics that occur at the boundary where the solar wind meets our planet's protective field, a crucial area that influences various space weather events. Mark Caro, a seasoned aerospace journalist with over 25 years of experience, is based in Houston. His extensive work has earned him recognition, including the prestigious Rotary National Award for Space Achievement Foundation in 2006, acknowledging his significant contributions to public knowledge about America's space endeavors through his reporting. For those interested in delving deeper into this groundbreaking mission, it is featured in the Aerospace Daily and Defense Report, a publication under the Aviation Week Intelligence Network, AWIN. Access to this insightful content is available through an AWIN membership. If you are already a member or have subscribed to the Aerospace Daily and Defense Report via your organization, you can easily log in with your email and password. If you haven't joined yet, now is the perfect time to discover how you can gain access to essential market intelligence and data that keeps you informed about the latest developments in the aerospace and defense sectors. But here's where it gets controversial. How much do we really understand about the solar wind's impact on our planet? As we push the boundaries of space exploration, are we prepared for the potential consequences of our findings? Join the conversation and share your thoughts in the comments below. NASA's TRACES mission launching on July 22, study Earth's magnetosphere. NASA is gearing up for an exciting launch of its TRACES mission, which stands for Tandem Reconnect Ion and Cusp Electrodynamics Reconnaissance Satellites. This mission is set to take off aboard a SpaceX Falcon 9 rocket during a launch window that opens at 2:13 p.m. Eastern Daylight Time, 11:13 a.m. Pacific Daylight Time, on Tuesday, July 22. The TRACES spacecraft, along with 3 other small satellites funded by NASA, will lift off from Space Launch Complex 4 East at Vandenberg Space Force Base in California. The primary goal of the TRACES mission is to investigate the interactions between the solar wind, a constant stream of charged particles emitted by the Sun, and Earth's magnetosphere, which is the area surrounding our planet that is influenced by its magnetic field. This research is crucial in today's technology-driven world, as fluctuations in space weather can disrupt power grids, interfere with communication satellites, and pose risks to astronauts in space. Understanding these interactions will help us better prepare for and mitigate the impacts of space weather events. In addition to the TRACES mission, this launch will also carry 3 other NASA-funded payloads. One of these is the Athena EPIC, Economical Payload Integration Cost, small sat, spearheaded by NASA's Langley Research Center in Hampton, Virginia. This innovative satellite aims to demonstrate a new, flexible approach to deploying remote sensing instruments into orbit more quickly and cost-effectively. Another payload is the Polylingual Experimental Terminal, PXT, a technology demonstration managed by NASA's Space Communications and Navigation, SCAN, program. This project will showcase advanced technology that allows missions to switch between different communication networks in space, similar to how mobile phones connect to various service providers on Earth. Lastly, the Relativistic Electron Atmospheric Loss, REAL, CubeSat, led by Dartmouth College in Hanover, New Hampshire, will utilize space as a testing ground to explore how high-energy particles from radiation belts around Earth are dispersed into the atmosphere. This research is vital for developing strategies to eliminate these harmful particles, thereby enhancing the protection of satellites and the essential ground systems they support. Notably, the REAL mission marks the first CubeSat launch for New Hampshire as part of NASA's CubeSat launch initiative, which aims to provide affordable access to space for educational institutions, museums, nonprofits, and NASA centers focused on workforce development. With the launch of REAL, a total of 39 U.S. states, along with the District of Columbia and Puerto Rico, will have participated in this initiative. The TRACES mission is under the leadership of David Miles from the University of Iowa, with assistance from the Southwest Research Institute located in San Antonio, Texas. The mission is overseen by NASA's Heliophysics Explorers Program Office at the Goddard Space Flight Center in Greenbelt, Maryland, which operates under the Heliophysics Division at NASA headquarters in Washington, D.C. Key instruments on TRACES that monitor variations in the magnetic and electric fields are led by teams from the University of Iowa, Southwest Research Institute, University of California, Los Angeles, and the University of California, Berkeley. Furthermore, NASA's Launch Services Program, based at the Kennedy Space Center in Florida, is responsible for managing the agency's venture class acquisition of dedicated and rideshare (VADR) contract.